Here it is given 1 minus x square y2 minus x y1 minus a square y equals to 0. This is equation 1, and we have to apply the Leibniz theorem to prove the given result this. Okay, so we will apply what is the Leibniz theorem. Just I am writing, that is dn of u, where dn represents the nth derivative of a given function. So what Leibniz says, nc0 dn of u v plus nc1 dn minus 1 u dv plus nc2 dn minus 2 u d square v plus and so on, at the last ncn u dn of v. Okay, so let us apply this Leibniz theorem to the given equation 1. Now see, this is the dn of 1 minus x square y2 minus x y1 minus a square y equal 0. As we have applied Leibniz, we will apply the Leibniz theorem in equation 1. Now let us do that. So it will split to 1 minus x square y2 minus dn of x y1 minus dn of a square y equal 0. So here we have three terms. This is the first term, this is the second term, and this is the third term. We will apply Leibniz theorem one by one to each. Let us do that. See, when we apply dn of 1 minus x square by 2, we have two functions. This is v, this is u. So simply apply that. It will become nc0 dn of y2, 1 minus x square will remain same, plus nc1 dn minus 1 of y2 d of 1 minus x square plus nc2 dn minus 2 of y2 d square of 1 minus x square. So the next term will become 0, as d cube is greater than the degree of the polynomial 1 minus x square. So no need to write that term. Simplify this. So nc0 is 1, dn of y2 will become yn plus 2, 1 minus x square will remain same, nc1 will become n, dn minus 1 y2 will become yn plus 1. Just add the power, this power and this suffix to get yn plus 1. Okay, now differentiate one time. 1 minus x square, it will give minus 2x. nc2 will become n minus 1 upon factorial 2. n minus 2, just add the power and the suffix, we will get yn. 2 times differentiation will provide you minus 2. So just cancel this both. We will get 1 minus x square yn plus 2 minus 2x n yn plus 1 minus n square minus n yn. Okay, so from first term we have evaluated this result. Now from second term, simply solve this. So dn of x y1, apply Leibniz, nc0 dn of y1, x will be there, nc1 dn minus 1 of y1, d of x will be there. So no need to write the next term because it will become 0. So nc0 is 1, dn of y1 is yn plus 1, x will be there, nc1 is n, add the power and the suffix, it will give you yn, dx is 1, the result is x times yn plus 1 plus n by n. Okay, so this is the second term. Now the third one is just see, it is dn of a square y. So the result is a square yn. Fine. So just add 1, 2 and 3 according to the given equation. Say that is equation 2. This equation is equation 2. So arranging in the same manner of equation 2, we will get, first write the highest order derivative of y, that is yn plus 2. So just writing that yn plus 2 and their coefficient is 1 minus x square. Now the coefficient of yn plus 1 we will arrange from all the three terms. So in this term the coefficient of yn plus 1 is minus 2xn, this one. Now the coefficient of yn plus 1 in the second term is x. So just write, actually there is minus sign also in the given expression this, so we will take it as minus, so minus x, just or you can write it minus of that, so minus of that, it will become minus of that, so minus is there. Okay, similarly the third term is also minus, so it is minus, that's why we have written minus of this. Okay, now the third term in yn, we have to write all the coefficients of yn, so it is minus n square minus n from the first one. From the second one we will get the coefficient of yn is minus n. Okay, now from the last one we will get the coefficient of yn is minus a square. So as we have taken already minus common, so we have to write this plus, we have to write this plus a square. Okay, so now simply arrange them, simplifying, it will become yn plus 2 times 1 minus x square, take minus 2x common, so minus 2x is common, it is x common. So when we take x common, it is in bracket 2n plus 1 of yn plus 1, and just write it minus n square minus n plus a square yn equal 0. So n to n cancel out. The final expression is, we can write it 1 minus x square yn plus 2 minus x 2n plus 1 yn plus 1 minus n square plus a square yn equal 0. So hence the result, this is what we have to prove after applying Leibnitz theorem. Just see this Leibniz theorem and prepare it very carefully. Thank you.